Lines and angles. Our objectives are to identify parallel, perpendicular, and skew lines, as well as identify the angles formed by two lines and a transversal. Who uses this? Card architects use playing cards to build structures that contain parallel and perpendicular planes. Parallel lines are coplanar and do not intersect. So if you look in the figure, line AB is parallel to line EF, and line EG is parallel to line FH. Perpendicular lines. They intersect at 90-degree angles. In the figure, line AB is perpendicular to line AE, and line EG is perpendicular to line GH. Skew lines are not coplanar. Skew lines are not parallel, but they don't intersect either. So if you look at the figure, line AB and line EG are skew. They're not on the same plane, but they're not parallel. So therefore they won't intersect. Parallel planes are planes that do not intersect. So in the figure, if you looked at plane ABE and plane CDG, they're parallel. Let's practice identifying types of lines and planes. Alright, so we need a pair of parallel segments. For example, you can have NK and ML. Or you might have SR and PQ. There are many others. Let's look at a pair of skew segments. So they're not parallel, but they're not going to intersect. So that might be NK and SR. Or maybe you grab NM and SP. Now we need a pair of perpendicular segments. So you might have NS and SR. Or maybe you grab LQ and QP. How about a pair of parallel planes? Well, you can look at maybe the top and the bottom. So we have plane K and M and plane S P Q. Or maybe you grab plane NKP and plane MLQ. There are other options for each of these. These are just a couple of examples. Let's look at angle pairs formed by a transversal. A transversal is a line that intersects two coplanar lines at two different points. The transversal T and the other two lines, R and S, form 8 angles. So your transversal cuts through two lines and forms 8 angles. Corresponding angles lie on the same side of the transversal T on the same sides of the lines R and S. I like to think of it as like the same place on each of the lines. So if you're on the left top of line R, you're going to be on the left top of line S. Or maybe you decided to grab the bottom right of line R, so the bottom right of line S would be 8. Those are your corresponding angles. Alternate interior angles are non-adjacent angles that lie on opposite sides of the transversal. So alternate, opposite sides, and they're interior, so interior, in between your two lines. Keep in mind, they're not 3 and 4 because they're adjacent. They have to be non-adjacent, so 3 and 6, or you could have 4 and 5. How about alternate exterior angles? Very similar to alternate interior, only these ones lie outside. So 1 and 8 or 2 and 7. Same side interior or consecutive interior angles lie on the same side of the transversal T between lines R and S. So 3 and 5 and 4 and 6. Let's practice classifying pairs of angles. Corresponding angles. Corresponding angles are in like the same position on each line. So angle 1 and angle 5 would be an example. Can you find 2 other examples? Take a moment and pause the video and try it. Now that you've had a chance to try it, see if your 2 other examples are any of the following. You can have angle 4 and angle 8, angle 2 and angle 6, or you could have angle 3 and angle 7. I don't think I missed any. Nope. Okay. How about alternate interior angles? Alternate opposite sides, and they need to be on the inside. So angle 4 and 6 would be an example. Can you find the other example? Take a moment and try. Okay, the other example is angle 3 and angle 5. So it's on opposite sides of the transversal, and they are non-adjacent. Okay, alternate exterior angles. Very similar to the alternate interior angles, only we're dealing outside, exterior. So angle 1 and angle 7 are an example. Can you find the other example? Try it out. Okay, the other one would be angle 2 and angle 8. Now let's look at same side interior angles. So we'd have angle 4 and angle 5. Can you find the other example? Take a moment and try. You should have gotten angle 3 and angle 6. Alright, let's step it up a notch. Identify angle pairs and transversals. So you want to be able to identify which line is being used as the transversal, and then classify the angle pair as to what it's doing. Is it alternate interior, alternate exterior, same side interior, or corresponding? So angle 1 and 5. First ask yourself the question, angle 1 and 5, which line deals with both angle 1 and 5? Alright, N is part of angle 1 and angle 5, so that's your transversal. Now we need to classify what type of angles they are. Alright, well they're in between our 2 other lines, and they're on opposite sides of the transversal. So you know they have to be alternate interior angles. Try B and C. Now that you've had a moment to try B and C, let's see how close you came. We have angle 3 and angle 6, angle 3, and angle 6. So your transversal is going to be M, and 3 and 6 are in the same position on the same side of the transversal, so you have corresponding angles. And now we have angle 1 and 4. Angle 1 and 4 both deal with line L, so L is your transversal. And then 1 and 4 are on the exterior, and they're alternate, so alternate exterior angles. And that concludes our lesson on lines and angles.